In this video, we're going to look at properties of the mean and variance, and in particular, we're going to look at these two formulas here, which represent a linear transformation of a random variable. And we use these two formulae when we define a new random variable from an existing random variable. So say, for example, I knew the average value for one particular random variable, and someone told me that a new random variable was twice that plus 2, I could simply take my average and work directly with that average. It's probably easiest with an example. So let's have a look at an example. Say that the time taken to build a house is described by a continuous random variable x. So I have one value that I'm measuring with a continuous random variable, and that is x. There's a new construction method that's been developed that can be represented by the formula n is equal to x on 2 plus 1. So basically this new method takes the old method's values, divides them by 2 and adds 1. So if I know some information about the original x value, I can work out some information about this new random variable. So if the expected time to build with the original method was 6 months, okay, so 6 months. So E with our original variable, E of x, is equal to 6. What's the expected build time for the new method? So that will be E of n. So what we obviously have to do is take this value of 6 here and pop it in this formula. That would give us the new build, yeah? So we would take the 6 divided by 2 and add 1 to find out the equivalent value for this new variable. And if we do that, so we get 6 divided by 2 is 3 plus 1, we get 4. So if we work through using these formulas, you can see we get exactly the same thing. So our n value here, I've replaced with the formula for n, which is now a linear transformation of x, because there's our x there. It's a linear transformation. And so I can use that linear transformation formula that takes the a at the front and brings it out the front of e of x. So it takes that half and brings it out the front of e of x. And then we just add the b on the end, so just plus 1 on the end. And what we end up with is exactly the formula that we used before when we did it logically. So the moral of the story is, if you get a linear transformation for your random variable, you can literally take the e of x value and work it out from here. You need to be really careful with the variance formula though, because that's slightly different. For the variance formula, it doesn't follow that pattern. You need to make sure that you're using this formula here. Now in the exercise, there is also a question around how the linear transformation changes the actual formula for the function that we use to describe x. Now that's way beyond the description of what we need to do in methods, so don't bother with any of those. But this linear transformation stuff of the mean, this is something that should now sit comfortably with the idea of just working with the x representing the average value. And then just remember, if you're doing a linear transformation for variance, you have to use the formula. Make sure you have this one in your bound book.